The recording has started. So let me share my screen. As usual, as I display my screen, I might not be knowing if you are raising your hands. So what you do is please unmute yourself and ask a question, anytime, whenever you feel like there is a question to be asked. Please do so. Okay. I will share the screen now. Please let me know if you can see the screen and if I am audible.
Yes, sir.
Yes, we can see it.
Yes. Okay. Okay. Thank you.
Yes, Asit.
Okay. So that's great. We are going to start a fresh session after we have learned Docker. We will do the Kubernetes after we have got an idea and overview of CI/CD pipeline, and we are taking the best CI/CD pipeline available in the market. See, GitLab was also very nice. First of all, Jenkins. Jenkins was the first pioneer who came up with all the tools for automation, CI/CD pipeline automation. Okay, but Jenkins had some. Jenkins is very popular still now. It is no doubt. But Jenkins, for that, we need to know a bit of Groovy. Shell is okay, but Shell has a limited capabilities over in to be used in Jenkins. Okay, so thereafter came the GitLab. GitLab was fantastic. GitLab, we can use entirely shell script, and you know the shell script is the best. I mean, best possible, easiest thing to learn and implement. So if a pipeline can support entirely on shell script, that is the best. So GitLab had its own way of using shell script, and that was very easy to learn. So in Kalki, we adopted GitLab because Jenkins had a lot of problems and people were starting complaint, because in Jenkins you need to keep or maintain a particular sort of a cluster. Okay, and wherever there is a certain thing that I need to do something extra to maintain a network of clusters, that is a bit difficult. That is not difficult, I will say, but that is adding to the complexity. Why should I make my life as it is? It is complicated. Why to complicate it more? So GitLab was the pioneer who has paved the way for simplicity within full automation, but simply doing it with shell script. After that, now GitLab had a competition with Azure. Azure is from Microsoft. Okay, Azure is a cloud. Initially, what Microsoft offered cloud was through Azure. Azure is the product or the brand name. Like AWS is from Amazon. So similarly, so the Azure portal was for the cloud, but Azure DevOps, many people have this confusion whether what is the difference between Azure portal or Azure and Azure DevOps. Azure DevOps is not cloud. First of all, Azure DevOps is from Microsoft Azure team, but it is having a separate set of or suite of tools. That is Azure DevOps, which includes one of the main tools is the CI/CD. There are 5 main products under that suite of applications called Azure DevOps, and one of the applications which is very famous is CI/CD. So like GitLab, we are going to introduce Azure DevOps. So GitLab and again GitHub or Git is not the same. Similarly, Azure and Azure DevOps are not the same. Azure is the cloud. Azure DevOps is the CI/CD pipeline. Azure DevOps is not CI/CD pipeline only. There are other. What are the other things that Azure DevOps? So let me maximize it. So is it fine? Can you see the bigger screen?
Yes, sir.
Yes, sir.
Okay,
Yes, sir.
okay, great. Now you see Azure DevOps from Microsoft. This is from Microsoft. Okay, has 5 products: Azure Boards, Azure Repos, Azure Pipelines. This is the most important part. And Azure Test Plans and Azure Artifacts. So it is like a product where these are the various tools under the product. And this is the main tool. All these will constitute for, like, you can start a project initiation, to project completion, a software development project. So the entire thing can be managed over using all the functions, or rather tools, provided within a suite of applications called Azure DevOps. Okay, Azure Board. Now this is for the project management part, like Jira. GitLab also has this part where you can manage the project from starting from the agile boards. I mean, agile planning and work tracking. Everything can be done. Work delegation or work management. Everything can be done as if you are doing a project management over with the help of Azure DevOps. One of the very important tool is the Azure boards. Okay. We will have 2 sessions today and the next weekend. I will try to, and this will be totally, it is very difficult to demo something over it. I can demo it, but that will not be that effective. Actually, we do Azure DevOps very thoroughly in our full-fledged program through, it is called a capstone project. Where the project will include Git, Docker, Terraform, Ansible, Kubernetes, and then Kubernetes, and using AWS Cloud along with AWS CLI, Linux shell scripts. So in fact, we are doing every integration with the Azure DevOps CI/CD pipeline. So CI/CD pipeline will integrate all these tools into a pipeline. So it will be something like this. Various milestones will be integrating of the various tools of DevOps. And finally, you are delivering to the pre-production or production box through the pipeline. So each and every part will be managed and delivered through a pipeline in a disciplined manner with an automation. So this is an entire project that we deliver, and we call it as a capstone. Capstone project is a live project, that is, some big company, Fortune 500 companies have used this sort of a project. So once you do a project like this, so all the things that you have learned so far will be in use, and you are doing them to integrate some. So basically, so a development package or development. Some developer has developed your entire development suite of tools or the development functions that will be actually delivered, tested, everything will be done, quality checked, everything over the pipeline, integrating all the tools of DevOps uh, into a release. You finally release it to for pre-production, for UAT, or for testing, for integration testing. And finally, when everything passes, it will go to the production. And therefore, it will go to the operations team for further monitoring, feedback, and all the stuff. So you can manage the entire project over the Azure boards. This is a different topic. We will not go into that. This is actually a project management topic. You can do the entire project. You can manage the entire project over the Agile boards, or sorry, the Azure boards. Azure Repos, like you have the Git repositories for source control. So it is like the Git repositories. So the developers are putting the development code or the source code into the either the Git repositories or directly into the Azure repos. So if you are using the entire Azure DevOps, so better if I can use the Azure repos. So all your development activities or development source code will be deposited over. You do not need to use Git. Git becomes a third-party external tool. But if you are provided with the repository itself within the Azure DevOps, so why not use it? So I do not have to go outside. That is like you enter a shopping mall, or in the market, there are small shops. You have to shop around. Okay, you have to hop around from one place to the other place. But here, when you enter the mall, all these shops are inbuilt within the, so you do not need to leave the mall because you can you can shop around within one complex. Similarly, think of this as a shopping mall with all the products available. You can manage your project. You can reposit all the development source code within the Azure Repos, which is another tool within the Azure DevOps. Then you do not need to use Jenkins or GitLab or some other pipeline tool. It is available within the Azure DevOps. So you go for one product only, all from Microsoft, and you can better use the CI/CD automation tool, the pipeline that I was saying. Also, you do not need to go to your, Selenium or JUnit or XUnit. You can test your code. The code can be tested through the Azure test plan. So manual and exploratory testing. So this testing is inbuilt. You do not need to go to another test server and install Selenium over there or Mockito. There are so many testing tools. You do not need to do that. You will have in the same mall, in the same shopping complex, one more product called Azure Test Plans. And finally, when you need to deposit your project artifacts, you can use another product called Azure Artifacts, which are used for package management. So whenever you build your package or build your code, there are artifacts which are generated for the project. You need to versioning, like release, first release 0.1, then release 0.2, and the final release may be 1.0. So all this, so something went wrong. Something went wrong in the final release after you have deployed into the pre-production. What you can do, or production, what you can do, there is some issues. You can roll back to the working version or release called 0.2. Okay. You do some modifications over there and then do the further release correctly, and you will get it back. So you can go back and forth with the releases. So every package, whatever the artifacts are coming out, you will store it. There is, so you do not need to have Nexus, or there are many artifactory tools, JFrog. They are very famous artifactory tools, artifactory. They are called artifactory. Nothing but in simple terms, you are using all the artifacts that are generated from your release and package management. All this needs to be stored for posterity, as well as if you need to roll back, you can always go back to the earlier artifacts which were generated for the 0.2 release. You will do some modifications over there, some more additions and alterations, and then can go to the next release. So instead of having an external third-party tool like Nexus or JFrog, not needed. You will use the Azure artifacts for package management. Is there any question over in this slide? These are the 5 main tools under the one package, one DevOps tool coming from Microsoft called Azure DevOps. So don't confuse DevOps and Azure separately. This is a product. Azure DevOps is one single product, and they have this 5 main products within that main product. Is it clear? Our focus is to learn about Azure pipelines. They are also fine, but for the time being, we will concentrate on Azure pipelines, the CI/CD automation tool. Is there any question?
No,
So can
sir.
I? Okay, so I will be moving ahead. So understanding CI/CD, continuous integration, continuous delivery, and benefits of CI/CD. So when you say continuous integration, what do you mean? Can you try? Anyone try? So what do you mean by continuous integration? Integration, without integration, this delivery has no meaning. So you have to integrate the various tools. So the practice of frequently merging code changes into a central repository followed by automated builds and tests. So see, CI/CD pipelines do not do everything or anything themselves. These are simple. They will integrate between all the other tools like Git. So the developers are putting their code into some repository called either Git or Azure DevOps Repos. Okay, Repos. So it's up to you. If you ask me, I will be using Git because Git is more popular and Git is widely used. Doesn't matter. So this is a repository. So a development, all the source code will be reposited in Git. I will integrate the Git tool over the pipeline, and that process is called integration. This is integration. Then, and there will be a trigger which will move forward the source code, and that code needs to be built. And after the build and packaging, it needs to be tested. But all these things will be done through some trigger points. There will be some trigger over the pipeline, which will trigger the next stage. Okay. So one stage after the other. So build will trigger the test. Test will trigger the deployment. Deployment will trigger the delivery. This helps detect integration issues early. So with the integration, what we actually do, we have an early detection. So the main motto of Agile, can anybody tell me what is the difference between Agile and the most important difference between Agile and Waterfall?
We don't know the errors in the process. Waterfall is
Okay.
directly in the end of in the end we know everything, like whether it is success or
Yes.
failure.
It is like steps. We are going by various stairs, one after the other, exit gate. These are all gates, one gate. So you have an approval process. You will say that you are exiting successfully from this gate. There are some exit criteria. Okay. You fulfill those criteria and then it will be passed, approved by the client. And you go to the next stage. Again, some exit criteria, passed. You go to the next stage, passed. And then you come to the final stage. Now, something goes wrong somewhere in the very end. You have to go back. Go back. This is not ideal. So at the end, if you fail in the very end, it is a disaster. So why don't you fail in the very beginning? Early failure detection. That is why you start it from the very early stage. Okay. And that is only done when you follow an agile methodology. Waterfall does not give you that particular facility. That is the best thing to do, is to fail early, because if you do not detect your defects in the very early stage, what can happen is a disaster in the very end, when you have exhausted all your resources, all your money, all your time. So basically, you are heading for a failure of the project. Whereas when you detect your failures earlier, it will be very good to know your drawbacks of your design, your development. Everything will be known at the very early stage. So you will get ample time to rectify those, and thereafter. So this automation helps a lot. So at any point of night, so during midnight, some developer has put in something into the Git, into the repository. Okay. And there is a trigger that some changes has happened over the existing stack. So that will trigger the next stage. So the pipeline will be triggered. So it will trigger the pipeline. Triggering the pipeline means I do not have to wait for the next morning, because it is in the midnight when the developer has put in something from somewhere. Let's say from India, some developer has put in some code into the repository which is in US. Okay, fine, doesn't matter. The pipeline will be triggered. The pipeline can be hosted anywhere. It will be triggered. So there is a build which will follow. There can be build. There can be a code validator called SonarQube, code quality check. It can be over here. So it will trigger the code quality checker or the SonarQube to check that whether the changes are according to the rules, whatever the rules laid down. And if it passes, then it will go to build. So this is happening automatically, unmanned. Nobody's there. No one is there in the development team or in the operations team or in the DevOps team, because that is happening in the middle of the night. This is the beauty of that automation. If the build fails, it will go back to the, so there will be a mail going back to the developer. There is a mail automatically, a feedback mail going to the developer with a report of what happened, why the build failed and everything, all the reasons, and the RCA. Okay, and then maybe next morning when the developer wakes up, he finds, okay, I have a mail saying that the build has failed. So it will go into the details of it and will rectify the code and again deposit or reposit it over the the Git repository. Again, there is a change, so that will trigger the pipeline, and again the Sonar Cube Sonar Cube will set in. It will check the code validation. Okay, if it passed, it will go to the build. Now the build passes. It will go to the next stage, package, but over the pipeline. So when it is morning in India, maybe US is sleeping. Doesn't matter, but the pipeline is active. So if the build is successful, it will package. Package is successful, it will go to deploy. The deploy is successful, it will go to deliver. So the code with the build artifacts will come down to the pre-production server. And it is now waiting for someone to trigger the start of UAT. All these things are there. So everything will be governed through the pipeline. So somebody will trigger the the release. So the testing will be initiated over here. This is called UAT. And therefore it goes on. So that is these tools, Sonar Cube, some build server, which is integrated over onto this pipeline. All these things, this is a Docker. Docker will package it. So Docker is integrated over onto the pipeline. So all this is a part of integration, CI, continuous integration. Now, the process of automatically deploying all code changes to a testing or production environment after the build and packaging stage. So here we have the Docker deployment. Okay, ensuring software can be released at any time. So it has been packaged as an image. We have learned about containers with image, and that image is nothing but the software that was put in by the developer. So this was deployed into its own environment, and then it will be delivered to a testing environment, maybe, or to a pre-production environment, maybe, or to a production environment in the final stage. With approval, of course. You cannot directly put anything into production environment. No. There is a mechanism of release management. These are called, so there are two pipelines. One is called build pipeline, and the other is called release pipeline. So basically it can be one, or it can be 1 and 2. You can segregate it out. It is the best way to split up your pipeline into two parts. One is build and packaging. So build, this is a very vital part. So building is very important part of the pipeline. So once the pipeline has been built successfully, or the development has been built successfully, then you can go into the release pipeline. Release has a lot of steps for the next day. I will show you on the tool itself, on the graphical tool called Azure DevOps. I will show you what are the stages. I cannot demo it right now, but I will show you the various things that happens inside the tool graphically. Okay, you will find it very interesting. So let us today only discuss about the theory part of it. Okay, now, so after this build, now it will go to a release, deployment and release. So that is called CD, continuous delivery, CD, which includes packaging, deployment, and release. That is called CD. So why it is very important that you need a CI/CD pipeline? Because you can reduce the delivery timelines. You can accelerate the delivery times, improved code quality, because you are building something within the integration of the pipeline. There is some Sonar cube. So the code quality is checked before you build it. If you stop the code at the this stage, that means you are not unnecessarily wasting your time in building and then debugging the build if it is not working. First of all, your code has to be of some standard, some quality check. So improved code quality. These are all happening automatically over the pipeline. Reduced manual errors. So basically, the more and more manually you interrupt, the more and more there are possibility for errors. So you are reducing the manual error part of it. The more automation, more better. But remember, you should not fully automate anything. That is the principle of automation. Do not go for full automation. Never. You should not achieve this. Should not be your goal. You have to go for optimal automation, not full. You must go for optimal automation. Because full automation can slow down your process sometimes. So you must go for optimal automation. Okay. Consistent and reliable releases. So this is also very important. You have to have a very consistent and release. So you do not go for haphazard or half-hearted releases. So take care of each and everything before you do the release. You should not keep something pending in the pipeline and then go for a release. That is a half-hearted release, and that cannot produce the quality that you are expecting. And faster feedback loops between development and operations team. So basically, it will always give a feedback. Every stage, there is a feedback mechanism. So that is very important. Any question over here? So we start from the base of the pyramid. Okay. So first of all, source control, the version management. So the development will put all the source code over into the version management. It can be Git. It can be Repos. Repos is Azure Repos. Okay. Or it can be Bitbucket, anything, any version control tool will do. Any source control. GitLab also is one of the version control tools. Anyway, so you put it over there. After that, it has to be compiled and packaged, and that is called build. Second stage, you see, there is a hammer. You are building it. Source control, the raw code comes into this storage, and thereafter it is pushed to the build. And then you see the scope. The scope, it's a huge area. Okay, all the scope has been put inside the source control. You are saying that you are narrowing down the possibility of error. Build, then testing. You are making all the possible flaws or defects. You are testing all those, and you are checking whether your requirements from the customer has been met. So validate the development process. You are validating it, testing, and then deploy. If the testing passes, you deploy it. Automate release to environments. So that is the release. So there can be a release pipeline separately or maybe the same pipeline. So up to this, so you can have this as one build pipeline, having source control, build and testing into one pipeline, and release. Release is also very important. So you can segregate it with a release pipeline. Build pipeline, release pipeline. So Azure Pipelines is the CI/CD service within Azure DevOps. See, within Azure DevOps is the product within which CI/CD is one of the services provided as Azure Pipelines that automatically builds, tests, deploys your code. It works with virtually any language, project type, and platform, supporting GitHub, GitLab, Bitbucket, and Azure Repos for source control. Build pipeline handles the CI aspect. So this build pipeline is CI. And this is release pipeline is CD. Handle the CI aspect by compiling code, running tests, and creating artifacts. Release pipelines manage the CD, the delivery processes, by deploying artifacts to different environments with approvals and gates. Approvals are very important. We will wait for the approval to happen. Only then we will release it to the gates. So any question over here? The picture is clear, right? CI/CD. Any question? So let me know if you have any questions. Don't hesitate. Okay. I will go back. Now, setting up your Azure DevOps environment. See, first of all, you will have to create your Microsoft account because entire thing will be the portal, the Microsoft Cloud, Azure DevOps. They are having the same Microsoft account. So you do not need to create one account for your portal and another account for your Azure DevOps. No, not needed. Okay, sign up for a Microsoft account if you don't already have one, or use your existing credentials to access Azure services. So Azure services means either go for the Azure Cloud portal, or Azure DevOps. So to use Azure DevOps, you cannot do without creating your organization. It is like that is the environment setup requirements. So it is like for Azure DevOps, I'm not talking about the Azure Cloud, okay, which is portal, Azure portal. I'm talking about Azure DevOps. Now, Azure DevOps, Azure DevOps, to start with, you need an organization. And from organization, after you have created your own organization, you can create your, what is the next stage? Under organization will come
Project.
Yes, the project. Because unless and until you do the project, you create your own project, it is like your own domain. Only then you can have all your Azure DevOps services like Azure Repos, Azure testing, Azure pipelines, Azure artifacts. Okay. So, but you have to create your. So after you create your organization, navigate to a devazure.com. That is the development server or the Azure DevOps server, which provides the Azure DevOps environment or Azure DevOps services, and create a new organization which serves as the container for your projects and teams and the teams. So basically, don't worry about the container. Container is not that container which is the Docker container. It is not the Docker container. It is just saying that you create your bucket for the project. Set up organizational policy, security, user access control. So you are basically managing the organization because that is very important. It is like a group. Under that group, you assign the policies, security, user access, all you assign it to the group or the organization. Better to say organization. You assign all policies, all security features, all user access controls to the organization. So whenever the project is imbibed or created out of this organization, so all this will also apply to the project. There can be multiple projects, project 1, project 2, project 3, P3, but all will have the same policies, same security, same user access and controls. Is that clear? Because you have put that into the organization. So you set up your organization policies, security, user access controls to align with your, it's a very interesting part. And after that, you create your project. Set up a new project with a name, description, visibility settings, public or private, and select your version control or whichever version control you want, whether you want Git or what. You can also go for, I suppose I do not want to use Git. What I can go for, which is
Azure
inbuilt
Repos.
in Azure Repos. Very good. So all these things you specify when you create a new project. It's very interesting. So basically you can create and work as a project. So Azure Repos, I will skip this because we have already, I assume that you already know Git. So Azure Repos is exactly what you have learned in Git. Okay, branching strategies, whatever you have learned in branching strategies in Git will also apply equally and same in Azure Repos. There is no difference. The concept, the technology remains the same. Only the product varies. And this is Git and this is Azure Repos. But exactly everything will remain the same. Push, pull, branching, everything will remain the same. That is called source control management, Azure Repos. YAML, we have already discussed YAML, what is YAML, and because when we write Azure DevOps pipeline scripts, that those scripts will be written in YAML. YAML means YAML format. Basically, this will be indentation, key value pairs, because it will follow Why key value pairs? You know, what is that term called? Key value format. What is this format called? Remember, we have discussed it is JSON, JavaScript object notation, key value pair, lists. So it's an array. List means an array. So you have an array of data, and then you assign this array as your items that you so specify in a YAML. You specify with a dash or a hyphen. Comments, you know, any comments that you want to give is with a hash. Multi-line strings. So you can have multiple strings using your pipe or this thing to say that you want to come from this line to the other line to the next line using a pipe. So some code here, and you want to continue to the next line so that your code is readable. So what do? You give a pipe and come to the next line. So that means this code is continuation. It is continued. We will not discuss that. Now, so in a pipeline structure, so we are saying that we are going to write pipeline, right? We are going to code the pipeline. So see, when you say I'm coding an infrastructure, what is that called? I'm coding infrastructure. Coding infrastructure. What is that term called? Infrastructure as a code. So here, what is the tool to do that? Terraform, right? So when you say I want to do the coding of the configuration, so configuration as a code. And what is the tool to do that?
Ansible.
Very good. Ansible. Similarly, you will code your pipeline. Pipeline is sort of a coding where the pipeline can be triggered. Pipeline will do some programming activities and all those stuff. So you will say pipeline as a code. Pipeline as a code. So you have to code it. How? They're very simple. You do entire thing with shell. And there are inbuilt. That is the beauty of this. You will get everything inbuilt within Microsoft Azure DevOps CI/CD tool pipeline. There are many inbuilt code snippets which are not, of course, written in shell script, but those can be called from the shell scripts. I will show you some code. Okay, how simple it is and how much work they do. But most of the things you are getting it inbuilt, and you have to just call them. So if you are doing some Terraform activities, there are code snippets that you call which are inbuilt. You just have to call them. So Terraform codes are available as you will execute them through the shell. Similarly, Ansible code snippets, You name it, everything is available as code snippets and you can get them. So again, there is a hierarchy, there is the step-by-step approach to building your pipeline script or pipeline structure. Okay. First of all, you have individual tasks or scripts to execute called steps. Through steps, you build the steps. And within each step, there can be jobs, group related steps that run on an agent. So there is an agent running which will execute a job. Okay. So one step can be one job or one step can have multiple jobs. So we start with the step, go to the jobs. Jobs can be organized into logical phases through stages. So one stage, let's say this is the build stage. And the build stage can have multiple jobs. Let's say two jobs, job 1 and job 2. But they are in the build stage. So each of these will be one job, and each of these jobs can be defined within steps. Okay. Then there is term called variables. There can be pipeline variables. And can anybody tell me what another type of variable will be available? Variable is nothing but you are storing some values into variables. As you know, variables are memory storage where you name the variable and those variables will be storing the values, and those values can be called within a job or outside the job. So one is pipeline variable, and what is another variable? There are two types of variables. I know I have not discussed that, but still, can you just guess? Wild guess, sort of. So pipeline variables are global variables. When you declare a variable within a pipeline, so that variable can be used anywhere inside any job. But if you declare a variable within a job, specifically inside a particular job, then that variable will be local variable or a job variable, local or a job variable. The scope of this variable dies when the job when the control of the code comes out of that job, or when the job finishes. When the scope of that variable, so you will not be able to use that local variable. If you try to use that variable from a job 1 for the variable that was declared in job 2, you will find an error because that scope is not within the job 1. But job 1 can use the variable which has been defined within the pipeline outside any job. That is called global. Is that fine? Triggers. So trigger, you have to define a trigger and define when the trigger should be fired after which event. Event-driven triggers. So whenever you hit that event, when that event happens or occurs, you will trigger that particular event. So it will say that now this is the so some developer has put in some code, some changes inside Repos or Git. That is the event which can trigger the pipeline. So you have to capture that event as a trigger point within the pipeline script. It will trigger, say, a job, say a build job or a build stage. Okay. It can trigger a stage, and within the stage there will be jobs. So it will trigger that job. Clear? So it will define when the pipeline should run automatically. Any question at this stage? So a YAML pipeline in Azure DevOps follows a hierarchical structure that enables flexible and complex workflow. This structure allows you to organize your CI/CD processes into logical components, facilitating reuse and maintainability of your pipeline definitions. Creating your first YAML pipeline. So it is easier to demonstrate rather than, but yeah, you can see. So where you start with creating your pipeline. So navigate to pipelines and click. So this is nothing but when you see the software, when you see that interface of Azure DevOps, you will know that there is how you will create organization, you will create your project, and under the project you will create your pipeline, a new pipeline. So you start with creating a new pipeline, then select the repository, whether you want to select your Git as your repository or Azure Repos as your repository, source code repository. You will configure the pipeline. Select a starter template or start from scratch. You can either use a template which is already, I mean, there are lots of templates already available for you within Microsoft Azure. So you can select one of the templates, but it is preferable to start your template without any template from the scratch. So you can configure your pipeline. You will start editing the YAML file. So whatever you write within that pipeline is YAML. Customize the pipeline configuration. See, everything is a configuration, though we are saying that you are coding, but it is after all a configuration. You are integrating. You are calling the plugins to integrate further into the pipeline. You are basically not doing anything, but you are stitching. Like the flower is available. You have to only stitch it into to create a garland. You are not creating the flower. Flower is there. Similarly, everything is there. The plugins are all there. You just have to customize the pipeline configuration. It's a configuration. And finally, when you are done, you save and run the pipeline. You will see you will commit the file and execute the pipeline. So you will typically name the file that you store as Azure pipelines.yaml. So YAML, either you say YAML or simply YML. Give some name. It is not necessary. This is the default name, but you must give some other name. And you must place the pipeline in the root directory. That is a mandatory convention. That is a convention. You cannot put your pipeline scripts anywhere other than the project root directory. Okay, because that is in the mother directory. From there, everything starts. So whenever you are executing the pipeline, it will look for the YAML script in the root folder, not anywhere else. If it doesn't find, it cannot. This approach is known as pipeline as a code. So PAC, PAAC, allows you to version your pipeline configuration alongside your application code. Any questions?
No, sir.
Okay. So this you do not worry about much. It seems to be a very complicated diagram. Don't look at this right hand side. Look at this particular thing. There are few types of triggers. Okay. This branch trigger is the most popular. So we will always use, most of us always use the branch triggers. So you start with a keyword called trigger. See, everything is like a key colon value. Why? Because in a YAML, you cannot write anything but a JSON structure. So everything is a key, and this is the main key. Under this, there is a sub key. Under this is another sub key, and thereafter, these are all the value. This is another key, and this is the value. So it is saying trigger from the branches include either the branch can be main, develop, or feature. It is up to you. You know, it can be master instead of main. It can be instead of develop, you can say development branch. It's up to how you have designed your source code. Source branches. So basically what it is saying that if you will trigger only if there is some, so when you say main, develop, feature, that means you basically, I will not go for so many things at the same time to trigger. So basically, what does it mean? Can anybody explain me what is actually happening? See, this is a very simple script. There is no complication. There is no complication. What it is trying to say? Anybody?
Whenever the code is pushed to that main branch or like those branches, it will trigger the event.
Yes, exactly. Correct. That means whenever there is any activity or any change in the main branch or the master branch or the develop or development branch or the feature, and following the feature, there can be any branch, any other folder which happens in under the feature branch will trigger the event, trigger the pipeline, you can say. But at the same time, you must exclude if under the feature there is something called experimental. You please exclude if anything has happened under this particular feature and under this folder. So you must anything under the feature, but excluding this one. So under the feature, there can be several other folders. Nothing is everything is fine only unless and until there is experimental, and if there are changes under this, so exclude those changes. These are for experimental purpose. It is not actually serious. So this is the most important and the most popular trigger. Then there is a pull request trigger. We will pull request PR branches include, so pull and request. And this is the cron. You know, cron means it is scheduler. You say, I will schedule a trigger, I will trigger an event when the clock strikes midnight, if there is any change in the main branch, I will start building it at this particular time. So 00 hours. So in the midnight, 12 o'clock in the midnight. So this is a cron job. This is not popular. This is not popular. This is very popular. And I will not say popular or not popular, not like that. It depends on your requirement. If there are lots of bad jobs, and bad jobs will need to be run in the middle of the night or in a particular time of the day, then you will schedule. So the keyword is schedule. Here the keyword is PR. Here the keyword is trigger. Any questions? I'm not going to the intricacy of the details of the code here, but you can see these are very structured things. You're not writing a Java program or C++. They are not. They are simple, declarative. What you want? What? Declarative scripts. Very simple, very, very simple. But it can do a lot of things. Okay, working with variables are definitely not very hard. It is very simple. There are lots of predefined variables. There are lots of user-defined variables. That means you can define your own variables. There can be variable groups. There can be secret variables where you can store your passwords or pass keys or credentials, security credentials, whatever in the secret variable. So this is a type of a variable, very important. So predefined variables, these are, let's say you want to define a variable which is a build number. So you will use that build package and under that build number. So you will get your system variable automatically defined and provided by Azure pipelines using. So a random number will be assigned whenever you use a variable like this. So some value will be assigned automatically according to the build. So the build is, let's say 001, first build. So next build, it can be 002. Anything, it can be, it is not that simple number. It's a random number and it has a, but you do not need to worry about, you just have to use that. It will automatically give you the current build number, right? Running build. Or you want to use the system.default working directory. Can you see this is the camel casing? There are multiple words, default, one word, working, one word, directory, one word. So each of them are starting with a capital letter. This is the camel casing. So system.default working directory. So whatever is system default directory is actually given to you. And let's say you do not know what is your OS that you are using. So you can say agent.os capital. It will give you the value. Whether the OS is Mac OS that you are using or it is Windows. You do not know. You just have to query this. What is the agent.os? It will give you that value. Or it is Linux. And for a particular version, it will give you that details. Is that clear? These are predefined. There are lots and lots of predefined variables. You can define your own variables. So these are user-defined variables, custom variables. You can say variables : project name : my app. So what is the variable name here? What is the variable name?
Project name.
Project name is the variable name. Can you see again? This is the camel casing, 2 words. So anything, the variables always will start with a not. I'm not talking of the predefined variable. The user defined. There is a convention of defining the variable name. Always start with a small letter, and the next word will start with a capital letter. Project name. Colon. So my app is the value. This is stored as a project. So what is the project name? My app. Build configuration. Again, you see it is small letter, and this is capital. Release. So these are user defined variables. Can you see this is a curly brace? So you can have array like variables, multiple variables in one declaration. You are declaring an array of variables, a collection of variables. This is a style of doing, or array. Or you can define as a variable group or secret variables. These two are very important when we work. Any questions? I know it's a bit boring at this stage. Now, in any pipeline, whether it's you are using Jenkins or you are using GitLab or you are using Azure DevOps, always there are build agents. There are two types of agents. Either it is hosted agent, that is Microsoft is giving you the agent. So what is an agent? Can anybody tell me? Just now, just moment back, we said that any job, when you execute it, who is going to execute? Are you going to execute it through some no, I do not have any capacity to execute any job, but there is someone who is executing your job. You just have to say that this is my job. I want to execute whatever the tasks within the job. But who is doing the tasks? Who is executing those tasks within the job? There is an agent. Agent is what is agent then? Did I install any agent anywhere? No. I have simply started by creating my organization. I have been given, you go to dev.azure.com. That is the portal. I mean, not portal. I mean, that is the site.com. And you open because you have a Microsoft Azure account. So you will be allowed to use this particular site. And you straight away start with creating your organization, and then you create your project, and then you create your pipeline, and you start your work. In the meantime, I have not configured any agent anywhere. How is the pipeline jobs working then? So agent is nothing but a server. The server is hosted by Microsoft. Somewhere in the cloud, somewhere in the Microsoft Azure cloud. Somewhere. I do not need to worry. I do not need to understand. I do not need to bother. So this is a server created for my organization. So as many projects I want to build, all this will be done in this server because you are using Microsoft hosted agents, pre-configured and maintained by Microsoft. So Microsoft is giving you this server to be used. Server is a physical server somewhere in the cloud. I do not need to worry about that. Running in Azure with Azure means Azure cloud. with multiple OS options, Windows, Linux. I cannot run a server without an OS, operating system. So the operating system can be Windows, can be Linux, can be Mac OS. Ideal for teams that want to avoid managing the infrastructure. So my company is a small size company. I do not maintain a data center. I do not have that much of money to maintain a data center with all the servers and infrastructure and the network. So what I will do, I will hire the services of Microsoft hosted agents. So I will hire this server. I do not need to create self-hosted agents. If I'm a big organization or medium-sized organization, I will for my better security. So these are public servers. Security is, of course, guaranteed by Microsoft. That is fine. But on top of it, I would like to, because I don't want, even if Microsoft is guaranteeing the security of the publicly hosted server, but still I have very, very sensitive data for my customers. I don't want to get it hacked or leaked or any violations. So I can have my own self-hosted agents run on your own hardware, providing control over environment and capabilities, beneficial for specialized build environments or when you need specific software installed. There are lots of softwares, you name it, it is there. But again, your company has a special software that is not available on the Microsoft hosted agents. So in that case, you will have your own self-hosted agents within the Microsoft DevOps, Azure DevOps. You can build it. There is a mechanism to do that. So are you getting me? What we are trying to say? So your agents can be Microsoft hosted, or you can yourself host your agents or create your servers on your own, because you need special type of software to be installed on that with special capability, protected environment or something like that. You're very customized. So you want to customize your environment. So go for self-hosted agents. This is very much popular with the organizations that maintain their own infrastructure. Agent pools. So collections of agents with similar capabilities that can be targeted by your pipeline. You can create custom pools for different types of builds or environments. Now, this is an agent pool, a pool of agents, servers. So you may be running multiple sort of environment platforms. Your applications are running over mixed platforms like Windows, Linux, Mac OS. Okay, so you can have a pool of agents, custom pools for different types of builds or environments. Agent capabilities, that's fine. It is not needed. Okay, any question? So how many slides it is 13. Okay, a few more. So basic build tasks. What are the build tasks? First of all, what is the first task? If I may ask you. Checking out the code. So that is checkout. If anybody has any idea of version control tools, VCS, okay, like Git or Bitbucket or GitLab, you know what you are doing. You are checking out your code. The first step in any build pipeline is retrieving source code from your repository. Check out. And there is another one called check-in. Check-in is actually you are putting in. So a developer puts in or checks in the code in the repository. in the repository. And then you pull out or check out that code into your Azure DevOps. Because now you want to process, integrate, and through a pipeline. So Azure DevOps.
So
So
can you
Yeah.
you explain like check-in and check-out? Like checkout is I understood. So what is check-in, sir?
Check-in means a developer, see, a developer is in India. Okay. And the Git server is somewhere on the cloud, somewhere in US maybe. Git server is nothing but a version control software server, version control system. We have to learn this Git. That is having lots of things, features through which there is a version controlling. Like we have seen something like in the Azure, sorry, AWS buckets, S3 buckets. We did versioning and stored few files. I hope in that demonstration I demonstrated what is version control.
Yes, sir.
Anyway, but Git is much more versatile. Azure buckets, sorry, S3 buckets definitely have a few of the features of version control, but not that elaborate. Git is actually meant for all those things. So a developer has written code, say, let's say Java code. Now those code .java files need to be checked in. So this is a repository. So there is a check-in of that code. That code has to be reposited with some version control facility. So the code is available over the source code, has been checked in by the developer. It is the developer who has checked in the code into the Git repository. But it should not be stored over here. There must be some mechanism. There is a pull mechanism. There is an agent which will poll. It will keep on polling. What is polling? You know the polling agent. There is a voting. In India, there was a voting in Bihar. Okay. So what happened in that voting? That there was polling agents. So it will poll. Leave it. Leave this. So there is an agent which checks on the Git server. So there are called, you know, I forgot the term. Something which the polling agent will check on the web, some web. I forgot that term. So that polling agent will check on this, on which is created on the Git server. So that will say that there is an activity, there is some developer has put in some code. So there is a change. So when the poll knows that there is a change, what it will do? It will check out that code changes, the new code that has come inside the Git, and it will pull. This will pull the code out of the source code and put it in the pipeline. So there is a trigger point. Immediately when there is a check-in by the developer into the Git So there is this term web plugin or something like that. It will inform the polling agent that yes, there is some change in the repository, please, or onto that branch. So whenever, so pipeline has been built that if there is an activity on that particular branch, like as you have seen earlier, main branch or master branch, as you have defined, that trigger, it will trigger the checkout to the pipeline. So the entire source code will be checked out into the pipeline, because your pipeline script has a trigger point. So whenever that web something will give that information of that there is some change into the polling agent, and therefore it will check out that code into the pipeline. Did I answer your question?
Yes, sir. Got it.
Hmm. So whenever there is some commit means change. That is a particular term used in any version control tool. You have committed some change, some check-in has happened. So there was a commit on a particular branch. So the developer knows which branch it has committed. So whenever there is, so you have written a pipeline in Azure Pipelines, you have written a code where you have said the trigger point, like the earlier I've said trigger colon this colon that. So whenever there is a particular branch included into the trigger point include, so mean, let's say dash mean. So there's a collection or list mean. So that means something has come into the main branch. It will trigger a checkout. If the event is checkout, that event will be triggered. What will it do? It will check out the entire source which has been put in by the developer into the Git, from the Git or from the Azure repos into the pipeline. Okay. Restoring dependencies. Most applications rely on external libraries and packages like NuGet restore. NuGet, you know, NuGet is for .NET, Microsoft. .NET is like you have the PHP, like you have the Java. Similarly, .NET is a Microsoft language. .NET comes from Microsoft. Java comes from Oracle. Earlier, Java was actually with Sun Microsystems. Now it is taken over by Oracle. Anyway, .NET is a Microsoft programming language. So .NET is actually compiler for .NET is the NuGet. Okay. Then there is npm install, pip install. Pip is for Python. So there are various tasks that will be inbuilt within the so the particular environment for your particular code. You can use this if you are using .NET as the source code. Okay, so that needs some building. So for that I need the environment to be restored. So with the NuGet I will get that. And where so this is like a plugin which is available within Azure DevOps, and I will use those plugins. I do not have to do any coding at all. I will call this plugin because this plugin will help me restore the environment for .NET applications. Okay. For Java, I will have the Maven restore. Maven. So all these are available within the library and packages of Azure DevOps. So ensuring all required dependencies are available before building. After that comes the main part, building the application. Compile the source code, that is whether it's Java source code or .NET or Python or PHP, anything. Compile the source code according to your dependencies that you have restored into executable artifacts. For Java, what is the artifact? Can anybody tell me? Dot, or rather it is jar or var. This is the executable. That is Java archive repository, archive files, and Java web archive. If it's a Java web application, the artifact, executable artifact is var. So it is a combination or a compilation of hundreds of Java files. But you are getting one file, one big file, executable file, using tasks specific to your technology stack, such as MS Build, Maven. So Maven is for Java, Gradle, or language specific compilers like NuGet for .NET, NPM for anything called, say, did you hear about React? Angular? So these are front ends, very, very powerful tools or thing. So that we can have the NPM environment with the backend as Node.js. But I will not discuss all this. That is not needed. You have everything in that library. You just according to you will be helped with the developer. The developer knows what are the actually the files that were developed. Okay, so he will say that, okay, is your Azure DevOps having a NuGet? And he will say, yes, I have. So, okay, I will need to build a script, pipeline script with the help of NuGet restore, which is already available in the library. That's all. You know how to get it. It's very simple call. And thereafter, all the checkout code, which is under .NET, will be compiled or built using this. I will show you the examples. You will come to know. Now, the last stage is creating the artifacts, which is packaging the build outputs. So after you have built it, like the jar or the var file, now this artifact, you need to package it, because without a packaging, you will not be able to deploy. Okay, so you need the packaging, the build outputs into deployable artifacts, which might involve creating zip files, Docker images. You see, this is very important. You know that you can package it as an image and you can deploy the container. That's all. NuGet packages or other distribution formats. Any question? See how organized this everything is. You know the concept. The concept is more important than actually doing it. If you are not having a right concept, it will you will face a bit of problem. Yes. How you are checking out the code. You are getting the environment according to the depending on the code. So you will build the environment according to the code. If it is Java, you will have Maven. If it is .NET, you will have NuGet. If it is React or Angular or New, okay, or Vue, you will have NPM. If it is Python, you will have PIP. After you have restored the dependency, you will build the application accordingly. I mean, this is all through jobs. This is one job. This is a job. So checking out the code is a job. Restoring the dependency is one job in a particular stage. Building is another job in the building stage, build stage. You can have stages, or you can, in one stage, you can have the various jobs. In one stage can have multiple jobs, or you can segregate out the stage. You have the checkout stage, under which you have the checkout job. Then another you can say restored, res depends, res dep, and there is another job. So this is one stage. This is another stage. This is one job under the checkout stage. Res dep and the job. Basically, this job will be restoring the dependency. Then you will have a build job, a build stage, under which you have the job to build the application. Or else you can have only one stage where you have all the three jobs. Any question over here?
No, sir.
Thank you. Now, you have also a very automated testing inside the pipeline. See, most of the people, most of the project team has a lot of issues with the various stages of the development. Okay, like checking out the code, building of the code, packaging it, and then finally test the packages. Testing is one of the most important and most critical, most complicated part of the entire process. But while you are doing the automation, your life becomes easier and easier and easier. So you will do automation testing over the pipeline. So you can do a unit test. Unit test is what? The unit test is yet the build has not yet gone to the testing team. So you are doing a peer review. Peer review means within the team, within the development team, you are unit testing the code between the peers. Execute tests that verify individual components function correctly in isolation. Test tasks vary by framework. VS Test for .NET, Jest for JavaScript, PyTest for Python, etc. So there are various framework. You just have to put it like uh, for Java, you have Maven. For Java, you have Maven. VS Test for .NET. So put it. So these are the unit testing tools which will automatically test your .NET code or JavaScript code by using Jest, Python code by using PyTest. So automatically the Python code, if you put it under PyTest, in the pipeline, it will automatically test all the features of that code written in Python. So you have to just configure the test runners to generate results in a format Azure pipeline can interpret. Integration testing, verify interactions between components and external systems. So whenever you do a system integration testing, here you do in isolation. Each of the components you do it separately. Here you will integrate all the components into verify interactions between the various components and external systems. These often require specialized setups, steps to prepare test environments, databases, or mock services. So here is the part where you can go for Selenium or JUnit or Mockito. Okay. Just integrate into the pipeline all these tools. They will do your part. Integration testing, code coverage. So there are lots of things that you can do actually. It's a very, very interesting subject. It is not just a 2 hour exercise. It needs a lot of detailed study. Basically, if you do one capstone project, your entire idea of using a CI/CD pipeline, how and how much, how far, will be all done in details. At least one capstone project you must do using Azure DevOps pipeline. As I told you, there is a lot of even within the Azure DevOps, you do not need to install or integrate SonarQube. Can you see SonarQube prepare? All these are inbuilt. Once you use the SonarQube integration, basically SonarQube is a very popular code checker. So the quality team will have SonarQube and you will integrate SonarQube into the pipeline. Static code analysis, if there is not dynamic code inbuilt, so you can use some static tools like ESLint, StyleCop, PyLint, examining your code without executing it, identifying potential bugs, style violations, and anti-patterns. There's a different testing world. We cannot go into much details. DevOps guys are not testers. Neither they are testers nor they are developers. Nor they are operations guys. I do not need to go into the details of this. Everything is integrated or everything is available. I know as a DevOps guy, I only need to know how to code, not code, script the pipeline, script the CI/CD pipeline, because I know the entire flow. I do not know anything of Java. I do not know anything of ESLint, PyLint, or Selenium, or Mockito, or JUnit, XUnit. I do not know. It is not my task to know the testing tools. Why should I know? I know how to integrate those testing tools into, or the quality code checker integrate it into my pipeline. So I will have this task. So I will get this plugin from my library of Azure DevOps. So I will just say task. I want to use SonarQube prepare. So don't worry about this numbering and the name, because you will get it from the library. I will show you. It is all inbuilt. You do not need to install SonarQube anywhere, because in that server, you know what is that server called?
Agent.
Yes, Microsoft hosted agent. Very good. Thank you. That agent has all these necessary tools and utilities and softwares that you need as plugins when you work. So this task is using SonarQube. Rest, everything will be taken care by this code snippet or plugin. This is a plugin for your checking the quality of the code. That's all. This is only the simple thing that I know I will do. The rest, everything will be taken care by the pipeline and by this particular plugin. How to check the code for the quality is determined by this particular plugin. That's all. If I want to use the SonarQube for analyzing the code, I will use SonarQube analyze something. If I want to use the after the SonarQube has analyzed and prepared and analyzed, I want to publish the result to the development team that whether it has passed the quality check. I will use this task. It is as simple as that. Though it sounds so complicated, so much, it is actually not. Everything is inbuilt for you. Then I can set up a quality gate saying that if the test pass rate is more than 95%, anything less than this, I will fail it. Code coverage should at least cover 80%. If anything like 75% code coverage has been done in that code, it will fail. So this is the quality markups. There should not be any critical bugs. So critical bugs should be 0. If I find even one critical bug, which is critical, but it's a bug, and then therefore I will fail. So this is the exit criteria. Exit criteria, I mean, say I'm passing out the gate. What is the pass criteria? I will have this exit criteria. That is 95% pass rate, code coverage 80% minimum or greater than 80%, and there must not be any critical bugs. It's very interesting subject. That is what I'm saying. So today I will leave up to this. I know it is a long session. Rest I will start from the next weekend. Rest of the slides. Is that fine?
Yes, sir.
Very good. So I will stop sharing today. And I will stop. Thank you. I will stop the recording as well. So Shubhro, if you are there, you can also stop the live recording. Thank you. So it is a bit bigger, big session. I will not hold you up any further. If you have any questions, please let me know, or else we will take up in the next session and we will complete at least our understanding. I cannot cover each and every aspect because generally in our full course, I take around 6 sessions, or if not less, if not more, 6 sessions minimum to cover Azure DevOps quite nicely. Each session is of 2.5 hours anyway, but so that is it. So it is quite interesting, fascinating, because you do a lot of things. We can do access all this practically. Yes, we have to do practical. See, theory is for your understanding, but unless and until you do hands-on, you will not be able to actually crack the interviews. Lots of hands-on has to be done. Everything is hands-on. If I cannot do a simple pipeline, I cannot set up a simple pipeline with integration of Terraform, Ansible, and then deploying it over Kubernetes. It will be a bit difficult for, like, the DevOps is in a matured status right these days. So it is not in a very beginner stage like it used to be in 5, 6 years, 7 years back. Okay, So now it is quite matured. So you have to go into a bit greater details and better depth, a bit depth. And how can you achieve that depth? Is only through doing lots of practice, lots of hands-on. It is very simple to listen, but whenever you start, like even creating a project with all the configuration setup can take a bit of, your patience. You will do it. You will do it. So we will have to do lots of hands-on, whether it's Docker, whether it's Terraform, whether it is Ansible. Why? Because see, you do not need to be a developer. No, no, not at all. You do not need to know Java, Python, and nothing. Yes, for any DevOps engineer, you need to know cloud very well. You need to know Linux servers, Linux, the operating system. You need to know shell script very well. If not very well, at least you need to be comfortable. Because after all, nowadays, everything is available through AI. Okay. So every other code, pipeline code and everything will, but if somewhere you get stuck, and after all, you have to get it customized. You have to have every requirement is unique. So you have to get the code from AI on. There are lots of documentation. There are lots of examples. You will get it from internet. But somehow, somewhere, if your concept is not clear, you will not be able to customize it according to the requirement of your company. That is the point where you will need to have a lots of hands-on. Then your concept is there, but you have to brush it up to hands-on. So, okay, this much for today. We will meet again on the next this coming Saturday. Thank you very much. Okay.
Thank you, sir.
Thank you. Thank you.
Thank you.
Thank you. Victor, you are almost 3 hours now. You have joined you are the first person to join, almost 30 minutes before the scheduled time. Thank you for that.
Hello, Mr. Debasis.
Thank you, Victor.
So this is Selassie. I was trying to find out, do you have any, are you teaching any classes currently?
So it is actually basically there is 8 sessions designed for the internship. That is 8 sessions means 8 weeks. 8 weeks means 2 months almost. But generally this particular cycle I am taking almost 2 sessions per topic. So it will be around 16. Yeah, it is basically 16.
Okay. Okay.
So another 3 sessions left. One more for this Azure DevOps, and another 2 for Kubernetes. Okay,
Okay.
another 2 sessions for Kubernetes.
was looking to join another class that you have going on. Um, I don't know when you would start a new session.
So the capstone project that you have asked, Kishore, will only happen in our main program, that is the job ready trainings, not in the internship session. Because for that we need to have a lot of detailed uh, exposure. Okay, thank you very much. I will take a leave now. Selasi, no, I have not yet started any because I am actually involved into a project uh, with a client. So my mornings, which is your evening in US, is almost like every day it is booked. So once that project is over, I will again start. Yeah, yeah. Okay. So okay, thank you. I will take a leave now.